This video contains the definition of specifications and real limit process. If we want to apply the Six Sigma methods and decrease the level of errors in our process, it's really important to know what is the difference between specifications and real limits. Well, at first, the specifications are generally the requirements that the customer wants, the customer specifications. And these specifications involve cost, quality, and delivery characteristics. For example, the size of the product, the material of some products, the form of something, and also the color and functionality of a product. All of these examples are the specifications that the customer wants in the determinate moment with a relative cost and quality. And what is the difference with the real limits? Well, the real limits of the process are the maximum and minimum values to produce all the products that we mentioned with the specification of clients. For example, imagine that we are cooking vegetables. In determinate time, we need to measure the temperature. Maybe we have a range to 70 and 80 degrees Celsius to have a good vegetables with good taste. So, if we obtain different values inside this range, we have a good product with the specification that the customer wants. We can mention that all these values are present in all the stage or step in the process product, and we must control all our process with the real limits. If we make possible that control, our process will be capable. That means controlling. Now imagine that you are in charge of production in the manufacturing plant of steel. To produce the steel is necessary to use scrap because it's the raw material to make steel. After that, the steel is melting between 1350 to 1700 degrees Celsius. Then it's necessary to take a sample to evaluate the composition of the metal, and if it's necessary, add more chemical components to increase the properties of the metal and decrease the defects in the final product. Finally, the metal is refining to make a steel with better chemical and mechanical makeup. Then the liquid metal going to the molds to obtain different forms, sizes, lengths, diameters, and different customer specifications. In each of these stages, the real limits of the process could be the range of temperature in the melting process, or maybe the range of air pressure to obtain the form, or maybe the range for the chemical composition, and etc. All these real limits stay in all the process, and it's important to be controlled to obtain the specification of the client. Well, why we need a capable process, and what is the relation with the requirement of the clients? Well, maybe the clients needs a steel with determined length, or maybe with determined mechanical characteristic, or maybe with determined heavy form, size, or maybe with determined property. So, to do this, we need to compare the natural variability of a stable process with the process specification limits. The variability in our process is natural and all the time exists, but we need to control and we need to have inside the specification limits and don't broken the wall. That means the specifications and the real limits. Thank you for your attention. That's all. Bye bye.